fits in the cloud infrastructure. So in this slide, if you look at the bottom, we've got a cloud infrastructure, and what all it includes, we have got a data center, which is going to be the part of the cloud infrastructure. And within the data center, we'll have certain entities, which I will just share. We'll have the virtual machines, we'll have the brokers, everyone will be a part of the data center. So on the right hand side, we got a virtual machine list. So this list can contain one instance of the virtual machine or many number of the instances of the virtual machine. So in the data center, we have got one virtual machine, two virtual machine, three virtual machine, nth number of virtual machine can be part of the data center. So data center can have a multiple number of the virtual machine, but it will have only one broker. Again, broker is a software process that is running on the data center, and what it will do, it will interact with the virtual machines. It will provide the services of the virtual machine to the user. That's the advantage of using a broker. So broker is any software process. It could be any process that can run on the data center. And what it can do, the biggest advantage of USP or using it is that it can handle, it can manage many number of the virtual machine directly at one go. Now that also raises the question, can I have multiple number of brokers? The answer is yes. You can have B1, B2, B3, B4, nth number of broker can be there. Can I have the multiple number virtual machine in a data center? Yes. I can have VM1, VM2, VM3, VM4. So theoretically speaking, there is no upper limit. It all depends upon the capability of the servers within the data centers. What is their configuration? How many number of virtual machines can be created? So broker can manage the virtual machines. So VM1, VM2, VM3, multiple number of virtual machines can be easily be managed. And data center can have one broker or it can have many number of brokers inside it. But in this diagram, we have got only one broker, and that is catering to three virtual machines at the same point of time. Now this was happening on the left hand side, right? Now we have got a demarcation line, that is what beyond data center, who will interact with the data center. So we require a user. User will generate a request and send it to the broker of the data center. But we need to perform the task of authentication and association. Means we need to check whether user is authenticated or not. So who will perform the authentication task for us? We'll have the software program called Cloudlets. So we'll have CL1, CL2, CL3, multiple number of the cloudlet can exist. So we have got instances of the cloudlet called CL1, CL2 and CL3. Same if you go further, we'll have many number of the CL2s, all the instances of the cloudlet. So the cloudlet list will contain instances of the cloudlet. So we can see three instances of CL are existing, CL1 are existing, three instances of CL2 are existing. Same way we can have multiple number of the instances of the cloudlet. And it may happen that one cloudlet list may not come to know about the existence of the other cloudlet list. So what they will do, करना क्या है, इनका purpose क्या है cloudlet का? They will allow the user to interact with the data centers, but they will check the privileges and permission. Is he a right person? Is he authenticated person? Can he do it or not? So first of all, the user will have to buy the cloud-based services. So user will be given the authentication credentials, login credentials, and using the login credentials, he can send a request to the broker of the data center. But Cloudlet will verify the credential first. So there are multiple number of the authentications. So like Kerberos is one of them, which is widely used for authentication. So Cloudlets can have the multiple number of authentication server inside them, which will check for the credentials of the user. Is he a right person or is he a hacker who is trying to hack into the data center? So here we can see the cloudlet list will interact with the broker of the data center, and the users, the end users, which could be a software process or could be actual physical user, he or she is going to interact with the cloudlet. So user will interact with the cloudlet, and the cloudlet are all part of the cloudlet list. So there are multiple instances. I can have one instance or multiple number of the instances of the cloudlet list. And what will this cloudless list do? They will allow me to interact with the broker. So I can have many number of the instances of the cloudlet. And all these instances of the cloudlet list will give me the permission, the power, the privileges to send my request to access the content from the data center. And who will give me the content from the data center? It's a virtual machine. And virtual machine we have all seen. It was first introduced by Popek and Goldberg. They came up with the idea that can we provide or can we create the instances of a real machine and give it to the users to access it remote from the remote location. If yes, then virtualization is holding good. If no, then virtualization falls. It fails in its effort. For example, I have taken the example of smartphone. In smartphone, I cannot use the concept of virtualization. But yes, in the cloud computing domain, all these big companies, the FANG group of companies, Facebook, Amazon, Adobe, Apple, Netflix, and Google, they perfectly use a virtualization concept wherein they create the multiple threads, multiple instances of the physical resource, and they bind each and every instance or the virtual instance of that particular resource to a client. So when a client logs in with his credential, he will be verified by the cloudlet program that whether he is a authenticated user or not. If he is authenticated user, then yes, his permission is allowed to him and he can log into the data center wherein his service will be, request will be processed by the broker, and broker will connect him to one of the virtual machines. So there are nth number of the virtual machine which are existing onto the data center, and the cloudlet will help you to forward your request to a broker will redirect to one of the virtual machine which is free at that point of time. It will bind or connect your request to that particular virtual machine, and that virtual machine will start providing a services to you. And how will recognize the user may be requesting a resource using smartphones, the mobile phones. So user use mobile phone is having the two kind of IDs, the IMEI number, international mobile equipment identity number, what we say the hard code number on the smartphone's motherboard it is present. And if I want to see that number, what is the digit I type? Star hash 06 hash. That help me to fetch the IMEI number of my handset. Or I can have the IMSI number, just like the number which we are having 98 series number, 97 series number, 99 numbers. So they are all 10-digit number, the mobile number which we share and we save in our contact list also. So user is having two IDs there when he is using a smartphone. Now when he is using a desktop PC or a laptop, then he is being recognized by the IP address and MAC address. So we can have the 32-bit IP address when we are using IPv4 addressing scheme, or 128-bit IP address when I'm using the IPv6 addressing scheme. So I can have any of these two addressing schemes. So I'll be recognized by my 32-bit address or 128-bit address. On the same line, I can use a MAC address, the 48-bit MAC address. So we all know 48-bit MAC address, media access control address work on the MAC layer of the OSI model. Whereas the IPv4 numbers, the 32-bit IP address will work onto the network layer of the OSI model. So when the user is sending a request to the data center, the broker of the data center will receive the request from the cloudlet. So cloudlet will first of all verify the user. Authentication will be done. That what it is IP address or MAC address, or what it is IMEI and IMSI number, and what are the login credential which have been issued to the user for accessing the cloud-based services from the data center. So when you buy a cloud-based service from the IBM or from the Google or Amazon, so they will all issue the login credential because you pay for your cloud services. So the billing can be per minute basis, per hour basis, per month basis. So you'll be issued a unique user ID and password or any other kind of login credentials. Nowadays, digital signatures are also used, wherein for the authentication purpose, these are being used, and then the user is allowed to access the content from the data centers. So that is how the concept works in the cloud infrastructure. On the right hand side, we'll have the users, the cloudlets. On the center part, we'll have the data centers, which can have the one server or many number of servers. The servers have the brokers. Again, they can have one broker, many number of the brokers. And broker can manage one virtual machine or many number of the virtual machine. So theoretically speaking, there is no upper limit. It all depends upon the technical configuration and the capacity of the server, how many number of virtual machine they can hold at any point of time. And when we talk the virtual machine, as I've already said, virtual machine is just a mimic or a replica of the physical machine. So using virtualization, I can create multiple small instances of the physical machine. Not only of the machine, I can create the logical instances of the different network devices like routers, switches, gateways. They're all available on the web. So user can be provided the resources to them. Even for the CPU, virtual CPUs exist. We have already seen the demo on the NIC Meghraj Cloud, wherein they are providing the virtual CPUs. I can have the instances for the RAMs, from the hard disk, from the any kind of the primary or secondary storage medias. So wherever virtualization is possible, we do it in the cloud computing domain. And where it is not possible, we don't use it. Like I took an example of the book in the library. I cannot create the instance of a physical book in the library. So it is being issued to you, and only you can use it for let's say 1 day or 15 days or 1 month. So virtualization is not possible in the physical entity. But yes, I can create an ebook. I can create a YouTube video. I can create any kind of other resources on the web, and the millions of people around the world can simultaneously access it, and it will be working as good as if it is only was designed to provide a services dedicatedly to you. Means as a user, you will not come to know that yes, multiple instances of that same physical resources are existing onto the web. That's the power of the virtualization, and it is a big hit. The entire distributed and the cloud computing domain uses the virtualization to its best of its ability. Now let's take an example how to implement this concept of the virtualization, how I can use it on a practical scenario. Means at the implementation level, at the coding level, how can I write the code for it? How can I use it? So let me open the Eclipse, and you can see the code, how I can implement it so that you can be able to correlate in a real-time scenario. So is the code visible to all? Anyone can say quick yes or no? Is the code visible?
Yes, sir.
Yes, sir.
Okay, fine. So here what I'm using the Eclipse IDE, and the code is written in Java, and I hope the code is will be able to understandable by you all, and everyone knows Java. That's a prerequisite for understanding this code of the tool. Otherwise, if the code is not clear, we won't be able to do it. So the IDE is Eclipse, and if you look on the left hand side, I've written here Cloud Sim. Now Cloud Sim is the name of the tool, the cloud simulation tool provided by the Manjra Soft Limited. It's an Australian based company founded by an Indian, Rajkumar Bhuiya, and is one of the pioneer in the era of the cloud computing. He has done a lot of good work, written a lot many research papers in the conferences and journals regarding the cloud computing. So if you want to work for your dissertation in the next semester, maybe if you are interested in cloud computing, you can take the cloud computing as one of the um, research-based projects, because a lot of things can be easily be done in the area of the cloud computing, and it's all implementation. It's implementation based. So if you enjoy coding, if you enjoy programming, then you can do a lot of good things in the area of the cloud computing. So on the left hand side, if you see here, I hope Cloud Sim is there. Then within the source, I got a program here. The two programs I've done here, Cloud Sim example 1 and Cloud Sim simulation examples. So if you're new to the Eclipse, how do we do it? We go to the file, we go to the new, and we create a Java project, right? So let's say I create a project. I don't know if this window is visible to you or not. So I can create a cloud project. Let's say 13th, it's in November, and I click on the finish. So I can see here on the left hand side where I got a project by the name Cloud November. So that's how we create a simple projects. Now within that we'll have the source. Within that I've created a package called program, and within the program I've got a program called Cloud Sim Example 1.java. Now let's try to understand the code, because understanding of the code is very important. Otherwise, you won't be able to get much knowledge about the code if you know the code is not clear to you. Now let's move from the very first line of code. First is package and the program. So I'm creating a package called program, and then we have imported certain libraries, what we call APIs or the packages in Java, from the line number 3 to line number 7. Now moving down from the line number 9 to line number 26, I've imported certain packages for the CloudSim tool. So if you can look here, CloudSim, Cloudlet, Cloud Infrastructure, uh, packages like Cloudlet Scheduler, Time Shared, Data Center Broker, Data Center Characteristics, Host, Log, PE, Storage, Utilization Model Full, VM, VM Allocation Policy Simple, VM Scheduler Time Shared, CloudSim, Provisioner Simple. So from the line number 9 to the line number 26, multiple kind of the packages have been imported. So what from where you will get when you are trying to execute a program, you need to download the full-fledged API library. So if you go to the left hand side, here I've got the GRE libraries and the reference libraries. So if you expand the reference libraries, here are the jar files present, right? So CloudSim 3.3 jar, the sources jar, CloudSim examples jar, CloudSim example sources dot. So I need to download this jar file onto my system. So once I've downloaded the jar file, I will add it within my folder which I've created in the CloudSim. So all the jar files have been downloaded and they've been added to the CloudSim folder, right? Now, if you look at this program, its program is all there. Now I'll come to the line number 31. I say public class CloudSim example 1. Now here, what I'm doing, I'm creating a class called CloudSim example. I think that should be very simple to understand. Then I further scroll down. I'm creating a list. The list is a data structure. Now what is the type of the list? It's a static type. And what's the name given here? Cloudlet list. So the list which I'm creating is of the Cloudlet type. And the name which I've given here is a Cloudlet list. Then moving down, I create another list, which is again a data structure. It is static type. The name which I'm going to use in my code, in my program, is a virtual machine list, the VM list. And what is the type of it? The VM type, the virtual machine type, right? Then we come to the line number 43, public static void main string and the args. Now that's a way how we define the main function within a Java programming language. Now public, why public? Because when you write a public, that means you are making the scope of your function accessible to all, everyone. Means all the classes and function of the same package or all the classes of function across the packages can easily access your main function. Even Java virtual machine can access your main function, right? Then static. Now in the case of Java, the main function is inside the class. Whereas in C++, the main function was outside the class. So there was no problem in accessing the main function within the C++ because the main function was defined outside the class. But in Java, what has been done, the main function has been blocked within a class. Now, once the main function is blocked within a class, and at this point of time, I have not instantiated the class, means reference variable of the object of the class is not available. Now, how will the JVM or the Java virtual machine will make a call to the main function when I have not even instantiated the class? So what solution has been provided by the Sun Microsystem, the company which created the Java programming language? They made the main function static in nature. Because once you make a function static in nature, then you can make a call to that function directly by its name. That means the function become independent of the object of a class. And now the JVM can directly make a call to the main function in one hop. Now it is no longer dependent upon the class instance. It is no longer binded to the object of the class. That's why we are using a keyword called static here. Void is the return type, which is simple to understand. I don't think there should be any problem. Main is the name of the function. Then we have got a string argument, uh, the string array called as args. So only thing that is changeable in this line of code is the name of the string array. Otherwise, I cannot change anything. It's all freeze. It's called hard coded. String, because Java by default receives everything as a string as an input. So that's why it is receiving as incoming argument of the string type. Line number 44, I print a log line on the log on the server, log.println and starting CloudSim example 1. So since it's the first program, so I write the starting CloudSim example 1. Then I start with the try catch part. Now in Java, exception handling is very important. If your code falls flat, if your code breaks down somewhere, then proper exception handling has to be done so that the system does not collapse. Means the software process keeps on running. So any line of code which is vulnerable, which can throw the exception during its execution, which can create problem during its execution, that line of code we must write within the try block. So since it's a code for the cloud-based services, and it may happen that the cloud-based service is not provided to you at the time when you are making a request, so I need to write the code within the try. Also, broker can create a problem. Also, cloudlets can create a problems. So it's very essential that all such line of code which handles with brokers, with virtual machines, with cloudlets, I must write within a try. And if certain exception is thrown, then I will handle the exception within the catch block. That's the advantage of using the try and catch in Java. And we also got finally block. Finally is always executed irrespective of the fact that exception is thrown or not from the try block. So try gives you the advantage of writing the lines of code which can create problem during its execution as such. So what do we do in the try? First thing what we do, we initialize a variable called number of user, which is an integer type variable. Since I'm only one user right now, so the at the server level, the number of user have been initialized to 1. However, it's going to be a positive number. You can increment the number to any point. So that means number of the instances of the virtual machines will be created. Then I need to specify the current date and time. So we make a call to the get instance function of the calendar class. It will help you to fetch the current date and time on which you are providing a services to the user. Then there's a variable called trace flag. If you want to do a tracing, more like a just like in C and C++, you used to press the F5 and control F5 and do the debugging. Same way, if I don't want to do the tracing, that if the services get collapsed somewhere, where actually the problem has arisen. So it's a Boolean variable. You set a value as a true or false. By default, it's all false. So here we are doing it for our own purpose. We can keep the value false, or I can change it. It all depends upon me. Then in line number 53, I'm making a call to the init function, the initialization function. Now, initialization function, we all know it's called only once in the life cycle of a program. I don't make a call to the initialization multiple number of the times. And it is a function being defined within the CloudSim class. So here, right at the top, if you see when we imported the packages, we made a call to the cloud. All multiple number of the packages were being called here. Cloudlet, cloud data centers, hosts, virtual machine. So multiple kind of the cloudlets are already present here. So here I'm making a call to the initialization function of the CloudSim. So CloudSim is the name of the class here. And you make a call to the function and you need to pass certain parameter to it. So what are the parameters I'm going to pass? The number of the user which are going to access the cloud-based services, the date and time, and the tracing, whether you want to allow it or not. Now, just like in the example which I showed in the PowerPoint slide, we created data center. So here also what we are doing here, we are making a call to the create data center function. And we pass the name of the data center here, data center underscore 0. Or I can even pass, let's say, a string, let's say India. I'm creating a data center by the name India. So you can make a call to the any of the, you can give any name of the string. And it is the name of the function create data center. So we in Java, we know the function always start with the lowercase. and the first alphabet of the function is always in the lowercase. And if the function contains multiple number of words, then the first alphabet of the next word always goes in the uppercase. So here D goes into the uppercase and the first C goes into the lowercase. Now if it is good, means if the data center could be created, the data center would be created by the name India, and it will return the information to data center class reference variable called data center 0. So data center 0 is the name of the reference variable which is pointing to a location in the memory where memory has been allocated to a data center called India. Now, once the data center is there in place, I can go and create the broker. So what do? I make a call to the create broker function. And once the create broker function is being called, and if the broker is being created successfully, it will return me data center broker class reference variable called the broker. So this broker is currently containing an instance of the broker. Now suppose broker cannot be created. So immediately it will throw the exception and control will go into the catch. Assuming everything is fine, we move on and we get the ID for the broker. Because whenever the broker will be created, it will have certain unique ID associated with it. So we get the ID of the newly created broker and we store into a variable called broker ID. So I hope the code is fine till line number 62. Any doubt, you can unmute and ask. Then we move on to line number 65 and we already get the VM list at the top on the line number 35, right? So here virtual machine list is there and now we provide a memory to it. So we make a call to one argument constructor of the virtual machine list. So VM list is equal to new array list VM and followed by opening closing parenthesis. That will make sure that the memory is allocated to a structure called virtual machine list. Now there are certain parameters associated with the virtual machine. So we specify one by one all of them. What is the virtual machine ID? So I can give any number to it. So let's say the first virtual machine, I specify the value as 0. Then what is going to be the speed, MIPS speed, million instruction per second. So let's say 1000 MIPS, that's going to be the processing power. Then what is the size? What is the size of the image it can handle at one point of time? So we are keeping it as 10,000 MB. That's kind of the image size it is going to be hold. Then what is the RAM currently it is holding? What is the RAM size of this virtual machine? So 512 MB of the RAM. I can increase it or decrease it. It is totally up to me. Then what is the bandwidth, the BW, which the machine can handle any given point of time on the web? So I'm giving it a 1000 KB. Then what is the number of the CPUs which are being provided by usage of this virtual machine? So by default, the minimum value will be 1. You can always increase the number of the CPUs which your server or your data center will provide. So minimum, I'm going to give it 1. Then what is the virtual machine manager name? VMM. So VMM is the name of the virtual machine manager. So let's say I'm keeping the name as